So I just kind of wanted to, start this morning by, kind of going back to sort of where we were and where we came from briefly, and then kind of talk about where we go forward. In the first two parts of the seminar, we really talked about, what are MBeans, how you create them, how do you expose your application data or and information through JMX and Coherence. So, connecting, issues with the distributed environment, how do you manage those and how do you move forward. But then the answer is, okay, so what, right? I put all this information out there. It's, and as we've all seen with, JMX and Coherence, you have kind of this explosion of information. The minute you start gathering, statistics on a node level, well, now you have possibly hundreds of nodes if you're capturing on a cache level or on a subcomponent level. It can then explode from there. And so you really can't view it in the standard JMX world, which was, console, right, or the HTTP adapter for those who are familiar with the 1.4 version of it. But then also, many of you own this thing called the Oracle Coherence Monitor, given to you by from SL, and you're now, okay, now what? How do I blend these two things together so that I can actually go about, trying to do analysis that goes across application to systemic within Coherence? And that is, when I first started writing this, I was like, I could talk for week and a half on that topic, and to get everybody up to speed on exactly how to do that in all detail. And I figured we didn't have that much time. So what we wanted to do today is kind of give you the architecture of, what are the pieces, give you the high level, know you need to do each part of it and what those parts are, and a brief, very simplistic example of how to actually go about it. And then, if we wanted to go forward and you want to learn more about this and say, hey, this is something I think would be valuable to me, what we can do is you can call Marie Oak at SL or send her an email, and we can either schedule follow-up training sessions or even, some consulting or whatever to actually help you build integrate your visualization, custom visualization into the analytics you already own within the OCM. So that's sort of where we went through and how we go. So let's just kind of move forward from here. Creation of standard dynamic MBeans is what we did. We talked about our different registrations for those of you using custom MBeans XML as well as the registry.register method. And one of the MBeans that we're going to use today was one that we've shown before, which is to create the query performance custom MBean that I wrote that basically allows the application to track how many queries of which type are going on and how long those queries are taking. So that was sort of the first part of this is what we're going to look at a little bit today. RTView and the tool RTView has several tools for helping you integrate, which is, we start with the builder. The builder is sort of a WYSIWYG painting tool to allow you to kind of visualize the data and then go out and kind of call functions. You don't have to write a lot of code to use the builder. You can actually use Zero and actually create things. It has a Java extension capability that allows you to extend with custom functions. But we're going to show you the builder today, and it is how you define the OCM screens and new screens for the OCM. And the general output of this thing is an XML file that is tagged with an extension of RTV instead of XML, but it's XML on the bottom end of it. And we just tagged it with our own file type to denote, what the format was. It's an older file. They created it many years ago, so that's why it got tagged the way it did. The nice thing about the builder is that once you've actually created something in the builder, we have runtime environment. So we have a rich client and a web client. one paint, one definition will work in both versions, so there's no bouncing between versions or even having to deal with it. The RTView environment deals with it. And then there are, when you're dealing with the OCM and you're dealing with the Coherence specific information, we have some specific functions that are, extremely valuable that were for the Coherence, and the two big ones are obviously the delta calculations. Delta calculations happen all the time. Once we got into Coherence, we noticed that all statistics are cumulative from the start of the JVM. So the JVM starts, it joins the cluster, it starts accumulating the statistics, and although the total is somewhat interesting, frequently you're more concerned about what's happened in the last period of time versus the beginning of time on the node. So you need to have delta calculations. We provide an easy way to help you with that. And then we have this concept of internal RTView cache. And we store a bunch of coherence information in these in these caches. And they are not coherence caches. And the reason they aren't, everybody asks, well, what's the difference? And the reason they're not is RTView and the monitor uses data in a time series of locations. So frequently we're doing a series of rows over and over again. Very, very rarely do you pull one row out of the RTView cache. You're going to pull many rows that have a time series associated with them to trend them, graph them, sum them. Where Coherence is a lot more, has an optimization of a more random access in the data elements, so you can go get, individual points in the information. So they have different levels of optimization. And so we store, a bunch of Coherence performance information in these RTView caches for you to go, reuse, reallocate, so you don't have to go out and, rebuild the wheel on the data that you're looking for. So that's the general overview. When somebody says, go build an RTView screen for Coherence, what are the pieces? What are the things you got to be able to go do? And first is, defining your JMX connectivity, your JMX query. What are those items? Then you're going to go out and build something called RTView functions. The RTView functions, they have a little bit of a sort of a lift type model where it's a process of processing multiple result sets through functions. So, you create a function that returns a result set that you pass to another function that takes that result set and cranks them out. And it allows you to transform the data from the raw JMX into something that is easily capable of visualizing. And when I have that n variables in it, the variables are there, obviously, input parameters created for things like, filtering or aggregations or things like that. And we have some of those available as well. We have within the OCM that are kind of predefined for you, as well as you can create your own for different filtering capabilities. You may need to create a cache, which is obviously optional. You'll define some visualization, a trim chart, a pie chart, a heat map, and then you got to deploy it. And you'll notice one thing that's very nice about the Oracle Coherence Monitor is it was built for extension and enhancements. So it's very simple to deploy your own files into the RTView or Coherence Monitor, and then you can deal with them as such. Now, when doing extensions and things like this, everyone who's ever modified a product that currently existed to customize it to their own needs, we do have to deal with some of the issues of, what happens when the underlying application changes and your changes are on top of them? Do you have to deal with it? And For hours, it will mostly be we're going to do today, which is a build on. We're not going to modify it. And it would normally run unless the actual underlying data structure has changed, which is normally an infrequent activity. So, we'll just talk about integration. Let's start in JMX connectivity. The OTM has two types that are normally used. One is a JMX RMI connection, where you have a remote connection from a remote node into the data source, which is Coherence. And we have a direct connection where we actually join the cluster as a node and pull the data through TCMP to the local node. The good news for you is when you're doing your integration, you don't need to worry about it. Right? We manage the connectivity, we manage the value, the way the hooks into the grid, and all you have to do is paint your JMX connection, and you're good to go. And you define a JMX query. So I'll just pull up a quick screen that kind of shows this, how you do it. And I did it in what we'll see a function. And right now what you're seeing is the builder. The builder, it's very WYSIWYG. It has little painters and it, lists of things that you can do to actually define your graphics. And what you're seeing here is sort of my output of defining my items, which were my cache, my query, how long it's taking, how many times I'm running each query, whether I have deltas here. So you're seeing sort of the maximum number of nanoseconds that things are running. And then I've got some pie charts and a little trend. What we're going to show you first is just how to actually define a query. This is relatively simple. You can go and select connection, and you'll notice I used this $ connection there. That's what we're talking about here. So when you're actually painting these things out, use $con as your connection when you bring up the builder, and then you don't need to worry about it. The actual environment can do it. Now you can find your own connections, which actually have the RMI IP and port, and that seems to be a lot more difficult. Use our infrastructure; it's there for the reason. Defining JMX queries. This you can simply find the definition in Googling on the JMX documentation. But, here is just the value of it right here. I've got a coherence type equal process stats star. Go get me all my process stats. We're going to pull for values so that we're just going to rotate through it. And we're just going to return all the data. And it provides you ability to actually select your columns if you so will choose. We take star. So that's how you basically define a query for coherence to pull data out of a JMX data source and paint it in the builder. So, once I've got my connection and I'm pulling my data, which is what I had at the beginning, what do I do next, right? So the most common things you're going to do is you're going to create a reference function. The reference function refers to your JMX source, and the reason why you mostly do that is if you decide to go back and change your source from either a JMX connection or you may go to a cache connection for the data. You don't need to worry about redoing your screens as much as you need to, and it will help you, remove some of the data. So do some filtering, and if you do a filter is simply, reduce the number of rows, and you're going to want to use a variable to do that. You'll also probably do delta calculations, which allows you to do it, and then you'll do some sort of group aggregation of some denomination to get the data out. And here I have some examples of how you basically do this. The delta calculation, which is we'll just look at a filter real quick. Okay. So here's a very easy filter. That's the reference, sorry. Let's just do the delta. Okay, the delta takes the reference of the data, sorted information, and basically allows you to say what columns are you going to do, what are your index columns. So this is basically how do you determine what the prior value is. So you take an index, you say, it's the process type, the service, the source ID, and basically I'm taking all the key values of this MBean. And then I'm going to take calculation on execution and execution nanos. So basically this will allow me to do the delta, maintain that list, deal with all the issues of maintaining a delta without actually having to do much work. Replace data with deltas. This is, do you want to keep, basically it says, do you want to keep the existing columns called execution count and execution nanos, or do you just want to create new columns called delta? And I have 0, it's a 0, 1 Boolean. I left 0 because I wanted to see both values. And do you want to keep negatives? Right? So if the values go up or down, do you want to keep them? In most coherence entities that you're going to look at, they're cumulative, so they are never 0, never negative. So you don't really have to worry about. Also a nice little place to give a description if you want. I was bad and did not add it. So this is just a very handy OCM-related function that was created to help you build out your, integrate your application data into Coherence, the Oracle Coherence Monitor. After you've done those, you're going to talk about, do a few filters, some delta calculations. Oops, I'm running a little short. I want to speed up. You'll do some delta calculations. You'll do a group by and a sum. Some common variables. You notice when I was doing the filter, I used service. We have service name, what the cache is, what the node is, the user time range. If any of you have used the OCM, which most of you have, you'll notice that we have many selectors within the architecture that allow you to pick, what cache is it, what cache or what service you're looking at. And by using the variables that you're looking at, you actually gain the ability to actually just reuse those selections. So then you can filter or move forward without having to recreate them as they go through. You can just use the current ones. We talked briefly about caches. RTView caches, if you're going to build one, they reduce the resource consumption on the cluster. You can gather things once. You can use local access while joining. You only have to do the delta calculations, which are somewhat heavy when you actually have a large amount of data.